Hello, this is Glenn Yancey with InSource Solutions. In today's video on Xperts on Tap, we're going to be covering the Communication Drivers Pack for 2020 R2. So in this video, we're going to discuss the newer installation for our communication drivers, which, as we have learned from a previous Xperts on Tap series, that the communication drivers are the newer terms for OI servers or DA servers. They're essentially the same technology, but just rebranded. So we're going to discuss the Communication Drivers Pack and some of the base drivers that are built in to the installation. And this installation that we're going to discuss is a single installation. With this version, you don't have to install the core and the driver. Most of the base drivers will be included with this install, and it does include the OI Core 3.0. So we'll quickly go through them, discuss what is new with each driver, if there is anything new, such as firmware, and we'll also discuss at the very end some commercial offerings for our communication drivers. So let's discuss our approach. The way that we end up communicating to our PLCs or VFDs or whatever other device that exists out there, in the SCADA world, we have to have a driver. So again, we used to call them OI servers or DA servers. And these drivers we now call communication drivers. So from AVEVA's perspective, we communicate already to PLCs. But that's not the only thing that exists out there. Other things that exist are remote devices that may speak what is called IoT. IoT is more of a concept than anything else. It stands for Internet of Things. And in the Internet of Things, we have a protocol called Mqtt. And that is the protocol that we use to communicate to these remote or edge-based devices. So that is becoming much more the norm in today's world. Also, we do speak to web-based components, such as web services. And we have drivers that will utilize either the REST or SOAP methods in communicating to these web services to perhaps pull in information like, let's just say, weather information. I want to see what the temperature and the humidity is for a specific zip code. And for whatever reason, I want to pull that into my SCADA system because I want to look at current weather environments for a specific pump station. So perhaps if you want to bring that in, then we'll have web-based drivers for that. And we also speak to telemetry devices. Also more remote-based devices, but a little bit more of an older technology to accommodate that. So we do speak all of these, and our approach is that we'll communicate to all of those, regardless of the SCADA package under the AVEVA portfolio. So again, we're just mentioning that in the past, our focus has been on PLCs, which is more the traditional connectivity, but now we have non-traditional connectivity, such as remote devices, getting data into the cloud, and so forth. So let's discuss this new installation feature. Now, the Communication Drivers Pack for 2020 R2 is a single install. It is embedded into the System Platform 2020 R2. So if you're installing System Platform or InTouch or Historian, there will now be an option in there for the communication drivers. However, let's just say that you're running version 2017 Update 3, Service Pack 1, or 2020 without using the Update 2, then you can still install a single version of the Communication Drivers Pack in addition to that installation. So in other words, if I'm still running that slightly older version of System Platform, but I want to utilize the newer drivers, I can still install the Communication Drivers Pack apart from the System Platform and get these base drivers and the OI Core 3.0. So this is what it would end up looking like inside of the installation. You'll see the AVEVA Communication Drivers Pack and all the different selections for the flavor or driver that you're looking for. And the nice thing about this is I can select multiple drivers at the same time to install and not have to do them separately. Nor do I have to install the OI Core separately. Now, there will be some instances that we'll discuss later on towards the end where I may end up having to install the communication drivers first and then later on install another flavor or driver for the PLC I might be using. Now, also keep in mind that if we are going to use this with an older version, then we need to make sure that we have the right operating system for communication and for installation. So the Windows 10s, these are the builds that we do support with this driver set, as well as 2012, 2016, and 2019, and Windows 8.1. So let's just quickly discuss the base drivers. The first driver that's included is a simulator, which we call sim. The simulator can be used to, if I have, let's say, graphics, and I want to at least test the graphics to make sure they work properly. I want to test my objects in my system platform application, or maybe from my in-touch tags, I like to at least get some things moving on the screen to make sure everything at least looks right. So the simulator can provide us with data that may not be coming from a PLC, but can still give us the impression that our SCADA system is working for testing purposes. So SIM is a great program that is now embedded into the communication drivers pack and that you can use. So there are different algorithms for your analog values and for your discretes. It's just either on or off. That's going to be pretty easy. Now, when you use simulator, by the way, with system platform, the beauty of that is I don't have to program anything. The simulator is already programmed for you. Now, maybe you can change your algorithm, but with system platform, there's a concept called I/O devices that allows you to drag and drop your instances of your objects to what is called a DI object. And by doing that, it will automatically bind to these addresses in my simulator without me having to define them. And that is just one great feature of this simulation product. I use it a lot in my demos and in my classes. So if you haven't played around with it, I would suggest at least installing the communication drivers pack and utilizing the sim simulator. The next is the ABCIP. The ABCIP is going to be for your Allen Bradley control logics, compact logics, micrologics, and a few of the other ones that you see here. We also support SLC 500s. That hasn't necessarily changed, but you will have to utilize an interface card for micrologics or compact logics to communicate to it. That's just with this driver. The next driver that we'll discuss will allow for direct connections to your SLC 505 PLCs. Now, this ABCIP also supports what is called auto build. Auto build is a means of replicating your structure, your UDTs, your templates, and your attributes in your PLC program and replicating that structure in your system platform Galaxy. And it just makes it a lot easier to pull that information in and know that it binds directly to your PLC code. Either you can do this in an online or offline fashion. So if you're not familiar with this, we'll quickly go into this. But to use the auto build functionality with a driver, you will need to make sure that you use the professional communication driver license. This does not work with the standard license. So before we go into that, just note that what I have highlighted in blue shows you the latest firmware that the ABCIP does support for these PLC types. So now let's quickly get into auto build, just as a refresher if you're not too familiar with it. So auto build, again, is replicating your structures in your PLC, again, like your UDTs, and bringing that in to create templates and instances inside of your system platform Galaxy. So there's going to be a lot of benefits from a customer perspective to bring everything in, but for your system integrators or SIs, this also allows you to develop much faster, provided that you have your PLC code already developed and utilizing what is called symbolic tag names. Symbolic tag names are just real tag names, not memory allocations. So this is a slightly older video, but this still demonstrates the concept of the auto build with the Allen Bradley control logics driver, or the CIP. So in that, there's going to be a build functionality. It's not going to be located as they're showing here. It's actually going to be inside of the configuration itself. So again, this is a slightly older video. But once you select that, then you can choose the mode of how you're going to bring this information in, as well as the Galaxy that you're going to connect to. So the auto build says I can either connect directly to a live PLC and pull my information in, or I can do this in an offline mode, which means I can bring in an export from my control logics program or compact logics and utilize that instead while I'm not connected to a PLC. So there's an offline mode. And on the right, you see where it says Galaxy. This allows me to point to the Galaxy and the area where I'm going to dump my instances. Now, from a system platform perspective, you just know that instances represent your real-world assets that are running live on your plant floor or in your facility. So after selecting that, then it's going to expose the instances or the UDT templates inside of your PLC program or PLC itself. So you select the instances, or sorry, the templates, and any instances on the right that were derived from these templates. So once that is selected, and you choose which instances you're going to bring in, you perhaps may not bring in all of them, but I can still select that. And it will take in your simple structures, contained structures, user-defined, and add-on instructions. It will then verify that these are the things you want to bring into the Galaxy. And as it continues verifying, then it will build your instances inside of the IDE for you. So in this case, you see here is my template that those instances were based off of, and these are the attributes that we just saw. And then it will also automatically keep that reference to your PLC itself. And this allows me to verify that those references that were brought in still connect and bring in actual values. So in this case, we have almost 7,000 values that were brought in within almost a 5-minute time frame. So that's the beauty of having auto build. So the AVCIP does support that, and we also are supporting the newer firmwares of your control logics, compact logics, and so forth. So the next driver we have is the ABTCP. This is more of the traditional Allen Bradley driver for PLC 5s and SLIC 500 series for direct Ethernet communication. Nothing too new with regards to this driver. It's just there's newer, much more of a newer code base inside of the driver. Same thing with the GE driver that we have, the GESRTP. These are the PLC types that are supported underneath it. Next is the Modbus Tcp for Modicon. This driver is also another base driver that allows us to communicate to Modbus-based PLCs, as well as any other device that can speak the Modbus protocol. So you do have some devices that have perhaps another protocol that they use for their first means of communication, and then you have a back end with your Modbus. So this allows me to communicate to that. The next base driver is the OnRON fins, and you can see the ones that are supported and the ones that unfortunately may work, but we can't guarantee the compatibility because they just haven't been tested. So it shows that down below. The next one is going to be the SI Direct, and this is going to be another driver where the auto build functionality is available for us. But just keep in mind, you have to have the professional driver, the Communications Driver Professional, or also known as the OI Server Professional driver. So we support the S7300. We don't support the S7200 series anymore. We support the S7400, and these are the ones that we have tested in-house. We support the S7-1200, and the 1200 does support symbolic mode. This means that we can utilize this for the auto build to connect into these S7, 1200, and 1500 PLCs that also are symbolic based, and do an auto build to replicate the structure inside of the PLC and bring that into the Galaxy. So the auto build at this point is just for system platform. There may be at a later point where it will be utilized for InTouch, but at this point it's just for system platform. So as you can see here, this is what we have in the SI Direct driver inside of my system management console. And as I have broken down the hierarchy down to symbolic, this is where I can reference the S7, 1200, and 1500 types and choose my auto build functionality for doing an online mode. And then choose my Galaxy and have it dump into, and create instances and dump that into the Galaxy. The next base is more of a standard rather than coming from supporting specific protocols from certain drivers. The gateway was once known as FS Gateway, then became OI Gateway, and now we just call it Gateway. This is our protocol converter. So whether or not you're going from OPC to TDE or SweetLink to OPC, or Opc Ua to SweetLink, then this is that protocol converter. So Gateway is in my opinion, is probably underutilized, because there are times where you need to communicate to old drivers that may not be Wonderware related, but they do speak perhaps OPC or Opc Ua, or maybe DDE, and I need to bring in information from those devices. So Gateway is one means of doing that, being a bit of a protocol converter. This also supports, as we mentioned earlier, the system platform, but exposing system platform as an Opc Ua server, which means that I can utilize Gateway to browse my system platform galaxy and pull in the items that I need to use for perhaps a different system, whether or not it's a third-party historian or other system, which I can't think of at this point, but you still need to utilize the addresses from your galaxy. This is one way to do that for third-party systems. So some of the newer features is that Gateway now supports what's called OpenSSL, which is more of a encryption-based protocol for the web. And the next driver that we have, skipped one. The Opc Ua is just mentioning that it's a standard, and a lot of PLCs are utilizing OPC on their front end for us to communicate to them directly without us having to use a specific Allen Bradley driver or Beckhoff driver. All we need to have in this case for these devices is an Opc Ua driver in our gateway. Turn that on, and then we can communicate to these devices. Next we have is the standards that represent the Internet of Things. The Internet of Things, or IoT, utilizes a protocol called Mqtt. And the Mqtt protocol, which we'll discuss in a little bit, is just more of a low-end protocol that allows us to communicate to edge-based devices or remote devices and pull them in whenever necessary. Perhaps maybe not consistently live, but we can still pull in values from our Mqtt server through what's called a payload. So let's quickly discuss what the payload is, and we'll discuss what this Spark Plug B support is going to do for us. Now, you can also see some of the newer features for this. It also supports the OpenSSL standard for Mqtt and the security layer that's attached on top of that. So with Mqtt, we may have a SCADA that exists on one end, our SCADA system, and we may have wind farms or pump stations or whatever they may be that sits out at remote sites that may be geographically distanced from us from maybe a very long distance. So in this case, we can see what the structure is of each individual windmill and the attributes that exist there. So what happens is we have edge devices that sits out there and pulls all this information in and makes that available through what is called a broker. An Mqtt broker is just a service that sits in the cloud that is handling, like a traffic cop, handling the data coming from remote sites into the SCADA system. Where our driver comes into play is that the Mqtt driver is designed to be a subscriber that talks to this broker and says, let me go ahead and expose the structure. Let me expose the payload, which the payload is just actual data that's getting transported, and maybe even monitor the states of these windmills or pump stations or whatever they may be. So the Spark Plug B gives us a standard on top of the Mqtt protocol to give us three things. So the main objectives that they use in this case is giving us a structure, or at least defining a structure for our devices, where I can drill down into their namespace, find the actual edge device, find the windmill itself, or the wind turbine that we saw earlier, and the actual attributes in them. The second thing that it provides for us is an actual structure for our payload. So again, when I'm saying this word payload, it's the actual data that's getting transported across the network through the broker and down into the subscriber, which in this case is going to be the Mqtt driver and system platform. So the third thing that it gives us is a state quality of our devices. So is our device up and running? Is that wind turbine that we have out there, is it running? Is it down for whatever reason? And if so, give us information whether or not it's live or it's dead. Now, dead may not be completely dead, but just not running at this time. So there are state-based quality codes that can come back and let me know if that windmill that I'm trying to get information from, if it's up and running or not. So Spark-Plug-B gives us a standard that sits on top of Mqtt that allows us to focus on the hierarchy of our objects on our remote sites, the structure of the payload, and the status of those devices. So in this case, you can see what the browser would look like inside of the Mqtt driver. After you connect to a broker, then it will display the structure of all the devices that are that you are referencing. So you have to reference a specific location, but once you do that for the broker, then it starts to expose this information. So what we see here are two locations in California for Central and for Northern, and you can see the further breakdown of the individual locations for, in this case, Santa Barbara for the central part of California, or down below you'll see Sacramento. Now, if I break that down for Santa Barbara, I can see the actual, maybe the wind farm that we have for each one of these, and expose the attributes for each wind farm. So as we expose the attributes, we can also turn on what's called geolocation. Geolocation can give us the longitude and latitude coordinates, which is also part of the Spark-Plug-B, and expose their locations on a map so I can even drill down and see where physically these wind farms are located. So it's a great, great tool that we have with Mqtt. But do keep in mind that the Mqtt functionality of the older gateway will be phased out because Mqtt now has its own driver. So just keep that in mind. The next base driver we have is the SNMP. This is for monitoring and managing our IP devices. So whether or not it's computers or switches or whatever that may be, we have this driver to monitor that information. So the SNMP OI server can again be utilized for switches and for computers. You just need to make sure that you have an SNMP agent on your computers or devices so that it can use that to manage and monitor the traffic. Next driver that we have is our web server or web services, and this allows us to communicate to any web service that can speak either the SOAP or REST-based protocols that are out there. So this is what the SOAP interface would look like inside of the web service driver, and this is what the REST-based interface for the driver would look like. It's a little bit similar to Mqtt in certain respects. You are referencing certain attributes through a certain structure, and the SOAP and REST will be the structures and protocols that we use for web-based services. So nothing necessarily new with regards to the web services other than an additional connection timeout on the REST connections. So this is just kind of a quick overview of what the data may look like in an XML or JSON data structure, getting passed through the web server and then brought through and exposing them as individual attributes that we can then link to our system platform objects and attributes of on their own. All right, so those were all of the base drivers. And as far as our commercial offerings, these are this is the layout. So if you don't have a license for the OI server, you can actually use up to 32 tags on a driver and not be licensed. So that's a great thing if you have a very small system and you don't necessarily want to purchase a communications driver license, or it may be cost prohibitive in that scenario, and you still want to use up to 32 tags, so you can do that in an unlicensed fashion. The standard license is the more traditional, used to be known as, I think, a DA server or device integration license way back in the day, then became the OI server standard, and now we just call it standard license. So there's no tag limit on this. It's just more the traditional means of communicating. The professional license does take it a step further, because one thing that an OI server and communications drivers can do that a DA server cannot do is do what's called a multi-instance, to where it can create multiple instances of a driver and stagger them with different update intervals and so forth, so that they are utilizing different CPUs in the computer itself. So I'm not tying up CPU 0 for all of my communications. This allows me to do that. Plus, if you're going to use the auto build functionality, you need to have a professional license to take advantage of that for your SI Direct for Siemens and for your ABCIP for your Allen Bradley. And the Premier license is for telemetry. So if you're going to utilize any remote devices that can use DNP3 or Modbus RTU or the IEC 60870, which is more of a European protocol, then you would need the Premier license for that. So just as a summary, this is a quick list of the drivers. The ones that are highlighted are the ones that are part of the base communication drivers. So now you just have one single install that you can choose for all of the highlighted drivers. Now, in the event that, let's say you're using an Automation Direct or a Koyo driver, then you would still install the communications driver, which does put the core on there. But if you need to use those drivers that are not part of the base, you will just have to download them from the AVEVA GCS website, and then it will install on top of the OI core. So this concludes today's video on Xperts on Tap for the Communication Drivers Pack for 2020 R2. Thank you again, and if you have any questions, please reach out to us and we'll do our best to answer them for you. Thank you very much.